Welcome to two examples on how to solve a linear inequality in one variable by graphing on the coordinate plane. A solution to an inequality contains all the values that satisfy the inequality. We most often solve inequalities algebraically, but in this video, we will solve linear inequalities in one variable by graphing. We use a technique called the intersection method, which means if we have a linear inequality in the form f of x is greater than g of x, or something similar to this with a different inequality symbol, we'll let the left side be equal to y1, the right side be equal to y2, and then we'll graph y1 and y2 on the same coordinate plane. Once we do this, we'll use the x value of the point of intersection to determine which x values actually satisfy the inequality. So going back to our first example, we're going to let the left side be equal to y1, so y1 is equal to 2x minus 3, and y2 is equal to positive 5. We want to know when y1 is less than y2, which would be when y1 is graphically below y2. To determine these x values, we'll actually use the intersection of the two lines as reference. Let's go ahead and enter y1 and y2. We'll press y equals, y1 is 2x minus 3, enter, and y2 is positive 5. It's important that we can tell these two lines apart. So for y2, we're going to go to the left of y2, press enter once, and now y2 will be a thick line. So again, our goal here is to find for which x values y1, or the thin line, is below y2, or the thick line. To make sure we have the standard window, let's press zoom 6. There's y1, there's y2. Let's calculate this point of intersection. We'll press second trace option 5, enter 3 times. The point of intersection is the point 4, 5, but notice how y1 of the thin line is below y2 of the thick line when x is less than 4 or on the left side of positive 4, meaning this piece of the line here. So that's our solution. X is less than 4. We didn't include positive 4 because that's when y1 was equal to y2. We only have less than, not less than or equal to. But sometimes we're also asked to express this solution on the number line as well as using interval notation. So let's go ahead and show that as well. If we want to graph x is less than 4, we would have a number line. We would have an open point on 4, and because x is less than 4, we'd have an arrow to the left. As we move to the left, we would actually be approaching negative infinity, which is helpful because if we wanted to express our solution using interval notation, we would have the open interval from negative infinity to positive 4. So we've expressed the solution in 3 ways: using an inequality, using a graph on the number line, and using interval notation. Let's go and take a look at a second example. Here we have 2 is greater than or equal to 12 minus 5x. So we'll let y1 be equal to positive 2, and y2 is going to be equal to 12 minus 5x. So we want to know graphically when would y1 be greater than or equal to y2, which would be when y1 is above or on y2. So in this case, we will include the point of intersection. Let's go back to the calculator, press y equals, clear out the old equations, and type in the new equations. y1 is 2, y2 is 12 minus 5x. And again, it's important that we tell these two lines apart, so we'll go to the far left of y2, press enter. Now, so y2 will be the thick line, and before we press graph, we want to know when y1 is greater than or equal to y2, or when the thin line is either on or above the thick line. So let's go ahead and press graph. Notice how the thin line is above the thick line on the right side of the screen. So let's find this point of intersection. We'll press second trace option 5, enter 3 times. The point of intersection is the point 2, 2. So because we don't know when y1 is greater than or equal to y2, or when the thin line is equal to or above the thick line, our solution is x is greater than or equal to positive 2. Let's go and show the graph of this on the number line. This time we include positive 2, so we'll make a closed point on positive 2. And x is greater than or equal to 2, so the arrow goes to the right, approaching positive infinity. So using interval notation, we'd have the interval that's closed on positive 2 to positive infinity. It's always open on infinity. So again, we've expressed the solution in 3 ways, using an inequality, using the number line, and using interval notation. I hope you found these 2 examples helpful.